In this section of the book, we're going to be studying trig functions, and there are 6 of them. The sine of theta, the cosine of theta, tangent of theta, cotangent of theta, secant of theta, and cosecant of theta. Most of the time when we use them, we're going to be using their abbreviations. So I'm going to show you what their abbreviations are. And when you answer questions that say, state the 6 trig functions of a certain angle, I want you to always write your answers in this format. So the abbreviation for sine is sin theta. Abbreviation for cosine, cosine theta. Abbreviation for tangent, tangent theta. Now, when you read the abbreviation, it's proper to say the whole word, even though you're only writing the abbreviation of the word. So I call this sine theta, even though I'm just writing the abbreviation. This is cosine theta. I don't go cos. I say cosine theta. So when I write it, I can write the abbreviation. When you say it, you always use the full word. And then the cosecant of theta, the secant of theta, and then the cotangent of theta. Again, always saying the complete word. Now, in terms of definitions of what they are, they're references to the sides of a triangle. So I'm going to draw a right triangle here in the first quadrant. Now you know the quadrants have numbers, number names. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So, based on this picture, and I put my theta here, the sine of this particular theta is the opposite side over the hypotenuse. Now, so when you have a right triangle, you need to identify where is the hypotenuse, where is the opposite side. Now, from the theta, if you were to go sort of in the middle of the theta line and draw a line straight across, that always hits the opposite side. So if you have trouble finding the opposite side. And then this side down here is the adjacent side. The hypotenuse and the adjacent side are the two sides that are formed if you wanted to look at the rays that form an angle. The adjacent side is also the initial side of the angle. The hypotenuse is also the terminal side of the angle. So the shortcut rules for this sine is opposite over hypotenuse. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And the reason I have you write them in this format is because the reciprocal functions are right next to the regular function. So the sine function and the cosecant functions are reciprocals of each other. How do I write the reciprocal of this? Hypotenuse over opposite. All right? How do I write the reciprocal of, that's kind of hard to see, isn't it? Right there. Let's see if that's a little bit better. The secant would be hypotenuse over adjacent. And the cotangent would be adjacent over opposite. So these are reciprocal functions. So when you're doing problems for me and you write them this way, it's very easy to get the answers to the reciprocal functions. If this answer was 3 over 4, this one would be 4 over 3. If this was negative 2 over 4, this would be negative 4 over 2. So writing them this way makes it really easy and quick to get the answers for the reciprocal functions. So now we're going to be drawing some triangles and identifying the trig functions for those, the 6 trig functions for some specific triangles. So if I gave you a triangle that had, let's see, suppose I had, this is 15. All right, this opposite side, do you think it's going to be bigger than 15 or smaller than 15? Hopefully you said smaller. And I can figure it out by using the trusty old Pythagorean Theorem. I know that 15 squared equals 9 squared plus x squared. So I can find that missing side. Okay, I already drew the triangle over here, so it's visually, I think, a little bit better to look at. So we have to find this missing side, which is the opposite side of the triangle. And one way is to use Pythagorean Theorem. So 15 squared equals 9 squared plus x squared. 225 equals 81 plus x squared. So x squared would equal 144. I'm subtracting 81 from both sides. X equals 12. Of course, when you take the square root, you know we could get plus or minus 12, so why am I putting just 12? It's the side of a triangle, it has to be positive. Okay, so now I have the three sides of this triangle, and I can do the six trig functions. So here's what I do. I write my little chart. Sine of theta, cosine theta, tangent theta, and the reciprocal one, so cosecant theta, secant theta, cotangent theta. And what is the sine of theta? It is opposite over hypotenuse, 12 over 15. And does that reduce to 4/5? So if they reduce, you want to reduce them. I said 4 over 5 there. All right, what is the cosine of this theta? You write it down first. 9 over 15. Hope you got it. And does that reduce? 3 goes into both, so 3 over 5. And then the tangent of theta, opposite over adjacent, 12 over 9, which reduces to 4 over 3. Now, you notice anything interesting about this pattern? It's really cool, but since these two fractions had the same bottoms, sine over cosine is tangent, so 12 over 15 over 9 over 15, that complex fraction reduces to 12 over 9. Basically, if the bottoms are the same, it's the tops, 12 over 9. Writing in this order visually gives you that. So this is 4/5, this is 3/5, this one's 4 over 3. All right, reciprocal function. So if this is 4/5, what's the cosecant? 5/4. What's the secant? 5/3. What's the cotangent? 3/4. So if you write the functions in this way, it'll be very easy for you to get all 6 answers very quickly. And you'll be able to check because they should always be reciprocals of each other. And we're not going to deal with any negative signs, but if the sine was negative, the cosecant would be negative. If the tangent was negative, cotangent would also be negative. So keep that in mind when you're doing this stuff. And you should be able to figure out the first few problems on the homework assignment. There's some pictures. If they give you a point to plot, say I give you the point 12, 5, and say find the 6 trig functions of that point. Sketch the point. It's over 12, all right, up 5, so pretend I went over 12. Over 12, up 5, and then I have to draw, always have a perpendicular with the x-axis, so this is the x-axis, and find the missing side, and this time it's the hypotenuse, and if you know anything about special triangles, you probably know that that's 13, but you could figure it out by going 12 squared plus 5 squared equals x squared. So you can figure these out if you need to. So good luck with the homework.